This call is now being recorded.
Okay, so the seventh question is basically like there are three members. Should be able to do this better, but okay. And each has its own dimension, and uh, the E is same for everyone. So what we have been asked is like what force we have to provide so that this end B, moves by a distance of zero point 0.3 millimeter. So what I've done is like I've taken these three members as three springs in a series combination, and for the value of stiffness we already know it's EA by L, and the effective uh, coefficient of stiffness, we know this relationship. So by this we'll get a distance, a displacement. Like so, we already know zero point 0.3 mm and 1.8 mm, and from that we'll get a force. So in this question, the different part is like it has a tensile or elastic end and a plastic end as well. So there is some plastic analysis is also there. In the plastic
Sorry,
condition,
bro.
what
Like, point three is what actually?
point 0.3 deflection we need
Overall
to
or
overall for end B. That's why I took a K effective.
okay, and 1.8 is
One point is it is also the deflection we need. It's for part two, like I'll
okay.
also
Oh,
say
so two forces we need. Okay,
exactly.
okay, okay.
So in this question, there's also a plastic behavior, and in plastic behavior, what happens is like the elongation, the strain, it will keep on increasing, irregardless of how much stress we provide. Like stress has reached its limit; it can't provide any more force. But if we provide this much force, we can get any deflection we want. Like we can keep on stretching. So if this happens, like we won't need more force than this. That's why I've taken the smallest member because it will have the highest stress. So I've taken that dimension, and it should be less than this yield stress. Otherwise, the plastic part will start. And if this starts, this force won't matter. Do you guys get this part? Like if we reach yield force, the elongation can be anything we want.
Yeah, we
So that's
understand.
why if the force
And the
calculated
yield point given is the maximum stress, right? That 4.2 into 10 power 4.
exactly,
Okay.
and if this force calculated is more, then we don't need it. The
So it will be
maximum
just the yield point stress, no?
exactly. That's
Okay.
the question. That was the seventh question. Now let's move on to the eighth one.
So like, what was it? Did you calculate whether it's lower or higher?
For me, both were lower only. Like yield stress was enough.
Okay.
Just calculate once yourself. And in this question, there's some thermal. I'll just. Can you see this?
So yield stress was lower than the required stress.
Yes. So
Okay. Okay.
in both cases, the forces were low. Matlab, I didn't need to calculate the force. It would yield force only. So in this question, we have a steel rod which is encased by an aluminum rod, an aluminum case basically. So what we are doing is we are heating from 15 degree to 38 degree, and what we have to calculate is the thermal stresses in the material and the forces developed on these supports. So to do that, what we do is uh, first we calculate how much temperature has changed, and from that we can get how much thermal strain we'll get. And as we know, the total strain is the calculate total sum of thermal strain plus elastic strain. So in this case, and a negative elastic strain will be there. The object wants to expand, but it can't. So it will develop some stresses. So the stresses calculated would be simply the elongation into modulus of elasticity, like this thermal strain into E, and from that we'll get for aluminum as well as steel. And to calculate the forces on the supports, all we have to do is the stress into the area of steel and the stress on the aluminum and into the area of steel aluminum. That would be the forces acting on the supports. It's that simple.
Hey bro, sorry, can you repeat this? Like this will be the for the steel rod, right? The stress.
For both, it would be the same only. Like steel rod has its own E, its own values,
Okay, okay.
and
And,
aluminum.
and like we don't have to think about the outward expansion and all, right? Just
No,
the
because it's constraint only. On both ends, it's
okay, okay,
constraint.
okay. And we'll just add up the forces from both
Yes, and
steel and aluminum.
this is from steel, this is from aluminum.
Okay.
Because the concept here is like the total strain is the sum of thermal plus elastic strain. In this case, elastic strain is zero, and thermal
No, bro.
strain.
Elastic strain will be there now. Like it will compress now.
Sorry. Total strain is zero. Like total
Uh-huh.
outward deflection is zero. That's why there is some negative elastic strain, like it's compressing, right?
Yeah.
And that's our sources of stress. So it's very straightforward. This is the like E into alpha delta T, alpha for alpha steel, delta T same, and E steel. That would be this, and E aluminum, alpha aluminum, delta T. It's that. So those were my question, guys.
No, I guess.
Hello.
Hello.
It's ninth question. I think Bindu, it's yours, right?
Yeah, bro. Yeah. Fine. So I'll continue.
Yeah.
Okay. Is it visible?
Yes.
Okay. So this is the ninth question. A steel hoop has to be shrunk fit onto a steel shaft. So what is happening is there's a shaft of 50 millimeter diameter, and the hoop has a diameter of 49.950 millimeter. So, and they're asking how high a temperature we have to heat in order to get a clearance of 0.025 when assembling the system. So, did you understand what this clearance means? Like the shaft is 50 millimeter diameter, and the ring inner diameter of the ring is 49.950. So it's 50 millimeter less actually.
That means to have clearance, you need to be small. The shaft needs to have a smaller diameter.
So this 25 millimeter outwards it has to extend. So how much should the diameter increase by? Can you think of that? From 49.950, it has to go to 50 plus
Okay.
0.25. Sorry. Oh, wait.
Okay, but how are you going to solve it? Like we can apply linear expansion only.
Yeah. 1 second. I think I might have made a mistake. 1 second. So 49.950. So it extends on both sides, right?
Yeah.
And on both sides, so the
On
actual
both
clearance
sides
should.
that
So the diameter will become 50.50, I think.
Clearance should be on both sides.
So
50.
so the diameter actually changes from 49.950 to 50.50. Sorry, 50.050.
Oh,
So the change in diameter is 1 millimeter. I have made a mistake here. Like I've assumed 0.75 and then multiplied by 2 for both sides. That's wrong. I'll have to change that. But the concept will be same. So
Just multiply answer by 4 by 3.
yeah. So delta C is equal to C alpha. So C is here is the circumference. I'm taking the linear expansion. So I've just and since circumference is equal to pi times the diameter, I've just cancelled out pi here, and the formula just becomes delta D equal to D alpha delta T. And since we know delta D is 0.1, 0.01, no, 0.1 millimeter, right?
0.1.
Yeah, from 49.950 has to become 50.050.
0.1 mm.
0.1 mm. So yeah, just multiply this by 4 by 3, I think. Yeah, 4 by 3. So this will be 0.1 actually, and the rest of the equation will be same. Alpha is given, delta T we just have to find. Equate delta T equal to 0.1 by 49.95 into 10 power minus 5, and we will get the change in temperature, how high we have to heat it. If you guys want, I'll just pull up the calculator and get the value.
We get the question.
And alpha is also given 10 into 10 power minus 6 per degree Celsius. So that's it. So next, any questions in this part?
No, this is fine.
Okay. And I'll stop presenting.
Yeah, next is mine. Can you guys see the screen?
Yeah.
Yes.
Yeah, in 10th question, we have to do like there's a flexible rod with a rigid flange, as shown here. A ring-shaped slider is held at rest above the flange. We have to determine the stress in the rod when the slider impacts the flange here and elongates the rod to its maximum displacement. So what we'll do in this question is,
Bro, can you stop presenting and start presenting again? My screen is stuck for you.
okay.
Wait. Stop. Wait, it's okay.
Wait
Can you
again.
start first?
Yeah. Can you see it now?
Yeah.
Yeah, in 10th question.
Hello. Yeah, right.
Hello.
I can see it.
You can see?
Yes, we can.
Like in 10th question, there's a flexible rod with a rigid flange attached to its lower end, and a ring-shaped slider is held at rest above the flange. We have to determine the stress in the rod when the slider impacts the flange and elongates the rod to its maximum displacement. And it's a pretty easy question. We have to use conservation of energy. Like energy stored at this position is half A delta max, delta square max. Using energy conservation and assuming no loss of energy in heat and sound, we get these equation. Mg is equal to L2 plus delta max equal to half K delta square max, where L2 plus delta max is the maximum length of the rod, and delta is the assuming the rod as a spring. Delta is the maximum displacement, and value of K, we can determine the value of K by using AE by L. Putting values in this equation, we get a quadratic equation of delta, and by solving this we can get the value of delta. Should I solve it?
No, it's okay.
It's fine. Quadratic, we have to just solve it, right?
Right.
We get a quadratic equation in delta, then we solve it, we get the value of delta. Like, any doubts?
No, it's easy.
Like, then we move on to question number 11. A load is supported as shown in the figure. We have to find at what angle it will result in least weight design if both members are stretched to yield y, and plot the normalized weight of the structure versus theta. Let's say both the members have forces FAB and FBC towards this direction and this direction, and FAB equal to FBC due to symmetry, and y is equal to F by A. So equating forces in vertical direction, get 2F sin theta equal to P, then 2F sin theta equal to P, then we get the value of F, that is P by 2 sin theta, and from here, like, this is L by 2, this total length is L, and this length is L, small l, then value of small l will be L by 2 cos theta, and W will be area into length into rho into G.
So I think it will be
And
two
from
times
equation
that.
1, 2 times what? Yeah.
The weight will
Here
be
we
2
get,
times that.
yeah. Then we also get 2 here. Yeah, area will be F by Y, so that will be P by 2 sin theta into Y. Then putting these values in equation number 3, we get W equal to 2P into L into rho into G upon Y by 2 sin theta 2 cos theta. 1, 2 will cancel out from this, and 2 sin theta cos theta will be sin 2 theta, and this 2 will be cancelled out. Then W will be P L rho G by Y sin 2 theta. That will be W is equal to P L rho G by 2Y into cosec 2 theta. Then we'll plot a graph between W and theta. We get from theta equal to 0, then W will be infinite, and theta pi by 2, then W also will be infinite, and theta at pi by 4 will be 1. So this is the question number 11. You guys have any doubt till here?
No.
Rishabh, any?
No, bro. Okay.
Okay.
Just we have to plot the graph only, na?
Uh-huh.
Okay, then it's done. I'll stop present.
Wait a second, guys. I will be presenting question number 12. Just give me a minute. I need to join with my laptop. Share. Now you can see. Hello.
Yeah, bro.
Okay. The problem is consider a bar of made from M segments, each having a constant cross section of a area AM. Okay. Like the bar is divided into M segments and each segment has area. Like this first area has area A1, the second one is A2, and so on. Okay. So like and also there is a loading, like first load is at D1 from this left side, second is at D2. P1, P2, P3 are the loads, uh, and we have been
Bro, is D1 the midpoint of the
no, not the midpoint. It can lie
L1?
anywhere on this red rod, like the total length. Yeah.
Okay, okay.
Hmm. So now the we have to do this, and we are we have been assigned to write a pseudocode to determine the normal stress at any specified location x. Like x from, you can see this x. This x is from any. Uh, no, this x can be any value from this left end. Solve for set of values for verification. How will you allow? How will you change the code to accommodate variable cross section area? Okay. Now let's go to the like what I did for the problem. Like the weekend needs to find the average stress, so it will be the load at n, like the axial normal force at x. Okay, this is normal axial force at x divided by the area. Okay, at that x, where normal nx is the normal axial force as a function of x. Also, a is the area of the cross section at some x, at the same x. Okay, in the given question, like area will change for what we have here. Area changes with the value L1, L2, and when we increase the distance, the area changes. So for like it's A1 for 0 to L1, and then A2 for L1 to L1 plus L2. Okay, and like so on till AM. Uh, you can see this, like you can just like this is just a mathematical representation, and this is nx. Nx is summation pi for all i's such that di is greater than x. Like I can show you here. We need to accommodate for those loads only that are to the right of the x. Like if this x is up to this one, we don't need to accommodate d1. Okay, we will add the loads from p2 to pn. Okay. Hello.
Yeah.
Yeah. So this will be the summation of pi for all I such that di is greater than 0. Hence we will calculate sigma average is equal to nx by a. Okay, simple. Now what I did, what I code for it, like I wrote this. Wait a second, I will do full screen. Okay, so this code I wrote. First I take inputs as I take inputs for n and m. N is like the total number of loads present, like 1 to p1, p2, p3, pn, so on. So there will be two arrays, pn and dn. Okay, and there is m, which accounts for the number of different cross-sectional areas. Okay, so that depends on value m. So uh, first we take input of n and m, then we make some arrays to store the values, and we do first enter the area and so on. like we will solve for a set of values. Okay, so what happens is then we take in the value of x. See, x is the distance from the left side, and this is C++. Like it's some different, something different from C. You all know, right? Hello, hello.
Yeah. But
Bindu has left. Why?
I think he's facing some internet issues.
Uh, in that case, we can wait for him.
Let's wait for a few minutes. He'll be
Yeah,
back.
you can stop recording and we will call him first.
Okay.
We can edit the recording, like cut this part.
Okay, he joined. Don't stop recording.
Sorry.
Hello,
Yeah, bro.
Bindu.
Sorry.
Where did you left? Right.
No. Like
Sorry.
you are explaining the code.
Okay. So this is I am saying that the language is C++, but I have used the scanf function, and this is like cout is printf only. Okay. So I was saying that
And
only.
this loops, you are just like checking where x
No,
lies in.
not these loops are for taking input. Like I am using scanf here.
Okay. Oh,
These
all
are
the
for
loadings and okay.
okay. These loops are for taking inputs like area input for areas for different L. You know what L is? Like L is the
But shouldn't it be M for all of these?
huh?
Like for the
No.
first two loops, you put M and then N for the second two loops.
Oh yeah, I will show you that. What for first two loops I put M because that's the area and length part. Like area AI and Li are this. Like I will show you. AI means the cross section from for this first part, and this Li is that length of that cross section. That's like length of that subsection you can say. Like
Okay.
subpart.
Oh, I get it. Like because the load is not applied on every member. No,
Yeah, it's not applied on every member.
it's
It's
independent.
yeah.
Okay.
So this we have M load, we have M subsections. Okay, so we will have M lengths, M of this L, and we will have M areas as well. Okay, and for the loading part we have N, like we have DN and PN. Like we have N loads, so we will have N number of Ds. You can know what D is. Like D is the total length from this.
Distance. Yeah. I got it.
Okay, so there is also some issues with my code. Okay, let's see. So then we ask for the value of x. Okay, and we take input of x, and what is this is the total load. Okay, I will start calculating total load. First what I do is like uh,
No, I think you have to check D.
yeah, no, what I did was like I didn't accommodate it like how D is we have D here like D1, D2 and Dn so on, but what's the problem with L? Like it's only the length of the subsection. So to compare length with x, like this part with x,
Oh, you have to add and all. No.
yeah, we have to add all that. So what I did here, so like we will check for oh, shit, no. I don't get it, guys. I am confused.
No, I think it's proper. Like you'll get the section before it. No. And now we need to add up all the loads after this section. Like J is the section, so comparable to M. So J plus one from J plus one, I think you should take two. You have to add up all the loads till M. No, M plus one. Sorry, because no M only. Sorry, because in arrays M only. No. Now, like I think next loop should be total force you're finding.
Like
After this,
I should have accounted for that, but I didn't see that the L is like of every subsection.
no, bro, this do while loop is proper. After this, I think you should count the loads.
I can
Or
do this for a second length is equal to L0. I can put, then that will be fine. Right. The first value stored in length is L0. And then we will do L plus plus, like where j is also 0. So we will j plus plus, then this will go to 1, and we will add length equal to L1. So and then we will check if L is, so j plus plus will be added, and finally we will put a j minus
Yeah,
1.
bro. If you do len equal to L of 0, you have to put while, not do while.
Yeah, that
Like
will also work.
think x is, see, say, take L0 as 10 centimeter and
Okay.
x as 5 centimeter and try to run this. Like simply first itself it will go to 1 simply, like even though it's less than x. So it should be while, not do while. Like you understood, not 10 centimeter and 5 centimeter.
Okay, we have now while length is less than n, like first if the first length will be less than equal to x, then it will do j plus plus. Okay, like
Uh-huh.
if L0, what will be my L0? Like here L1 is there, so consider this to be L0. If this is smaller than x, then it will go to add this L2, and the area will be changed to A2.
Yeah.
Okay, so it's nice on it. Okay, so where were we? Okay, now what I did is, like, we have accounted for the subsection part, like we know which subsection we are in. Okay, from 0 to
Yeah.
0 to m we will have some section. So, and now I am using I to store the total load. Like what I have created another variable, load equal to 0. Oh, wait. Yeah, load equal to 0. I don't think this will work. Okay, load equal to 0, then what we do is, like, if di is greater than x, we check for every I. Okay, if that di is greater than x, like if that load is present at some values greater than x, like if d1 is present at d1 is greater than x, then we will add p1. That's what we did in this PDF also. That's what we write for all I such that di is greater than x. We will do that. Not even a smaller one or equal to I am also not taking, considering, like, we will be calculating for the right part only, na, like for at x, like we will pulling it to right, so I am not considering the load at di as well. Do you know, like, the load at exact x. Okay, so hello Bindu.
Yeah, bro.
Yeah,
I'm
so
following you.
like if di is greater than x, then we add pi to the load for I equal to n. For every n we do this. Okay, and then we see out load divided by aj. That's what we planned in this PDF. Sigma average is equal to nx divided by a. Then what we need to do is, like, we have to run for a. So I want you guys to come up with a. I just I want you guys to come up with a sample. Like, we will make some inputs and check if the code is working perfectly.
So 4 sections will take.
Let me first run the code. Yeah, 4.
Whatever. No match for operators.
Yeah. Hmm? First, EJ. Why is it having compilation error?
What happened? Did you try compiling again?
Yeah. Can you see the screen?
I think you should put C out that load by A of j in brackets.
No, this is the problem. This is what the problem.
Okay.
Yeah, like, please enter the number of loads n and different and number of different cross sections. Like,
3 loads and 4 sections is fine, no?
okay, you can come up with whatever you want. Like, we will enter for n and m first. So first we need to enter n. So I will, whatever you want, I can 4 or 5 we can take 4 and 6 or whatever you want. Like let's enter 5 loads. Okay, like 5n, that means there will be 5 loads, and let's make 6 cross sections. Okay, now it asks me for 5 values of areas and 5 values of L, and we will have to enter
6 values of area, bro.
yeah, 6 values of. Okay, so what we should do is suggest me something.
Like try 2 and 7. I guess this is in meter square only, no?
Yeah, 2, 7, 5, 6, 5, 6. Like we can use float for them. I have like we can use anything like 5.5.
But for checking, let's do with integers.
No, not
Bro,
I want to. So
no,
okay,
bro, we have to check once, no? Calculate and check also, no?
7. Okay, this is the 6 areas we have. Like starting from the left, 2, 7, 5, 6, and 5, 7. Now we will enter the. Okay, now we will enter 6 L, like the number of, like for now let's make it like average cross section is 1 meter long. Okay, so that won't be a problem for us. This, and now we will enter the values of
The loads.
the loads. You can.
Bro, I think you made length like 1 meters, no? So now D will have to be in fractions. I guess, I think so.
No, yeah, D can be in fraction. I have did all. I can do that.
Okay. Yeah, we'll calculate that. Fine.
Okay, so let's have D. For the first, let me
First P.
first P, yeah, first P. So what are the loads? I can like 2, 3, 4, 1, 5. Okay, these are like the 5 loads applied at like now the D will be the D in the question is like the total distance from the left. So
so total distance, total length is 6 meters. No?
Okay, so for that we need to keep it under 6. Okay. Yeah. So now
and it should be a ascending order. Don't forget that.
we can do anything, like it will add it will add this 2 if it's if D 2.1
yeah.
you can do anything, but yeah, in the question it's an ascending order, so we'll do like that. Let's say 1.7, let's say 2, let's say I don't know if 2 will, like I can put it in 1.2.
Yeah, you can put 2.
2.3. I will don't know, but that won't be, that will be excluded.
No,
from
it will
the
convert. It will convert to float, I think.
Oh no, that's not the case. Like 2 is a from this.
Exact. Okay. Okay.
So then we will have 2.9. How much I have done? Like 4 were there.
For 3.5 and.
Okay.
Okay.
Now we
4.
can do enter. It asks for the value of x. So
try 0.5.
0.5.
Yeah. Like, okay, wait, this will run only once now. We have to enter the whole values again.
Yeah.
So try 2.5.
Okay, 2.5. Now it gives 1.2 as answer. So let's just calculate, like at 2.5 what's the, like after 2.5 there are only 2 loads, 2.91 and 4.3. Like we have 2 loads, 6 loads are there, and the area at 2.5 should be, like we have first area change at 2, and after that we will change area at 3. Okay, so from
it should
2
be
to 3,
5, no?
from 2 to 3 the area is 5, so we can know how this is. This will be like
wait, 6 by 5. 6 by
6
5.
divided 5, that's why it gives the answer 1.2.
Okay.
So this is how we calculate the load. And there is another part on the question. It says like we need to check it once. So what I did is was checking it, the code, and like how will you change the code to accommodate for variable x? Okay, variable cross section area. So what we will do is like we will have something like this. Okay, so this the previously only n was the function of x and area keeps constant for some value. So that was also a kind of function, but we can write area as a function of x, and in the code we can put area equal to in the code, and we don't have to do anything for area. We will get area just putting the value of x. This will calculate ax, and then we will do where ax is area. So then we will get the sigma alpha. That's only the change we need to make in the code. So like you guys want me to do that also.
No, that's fine.
Like we can remove this part. Like this part will be removed, and we will define area as like backspace. Okay,
Like
so
length we need, not
yeah, after getting the value of x. Okay, hello.
no, bro. We should take input of length now, but
What input of length?
L of m.
No, we don't need, like what in questions it said, like we need to encounter for variable cross section. So what I'm saying is like the
Oh, okay. You are saying
some
like it's continuous. Okay, okay.
some complex function of x, area is some complex function of x. So what we will do is like in code we will put after
Okay. So just that deal
yeah,
checking
and we
for
have
D and then
x values, so we can calculate area is like area is equal to x raised to the power 3 or x square something, x square plus 5, like this, and we will get the area, and then we will divide it. Okay, so this is the problem number 12. Like, is there any doubt? Like, it felt more like a CS question.
It was a CS question. Like mechanical part was very limited.
Yeah, like nothing was there in the mechanics. Like it was only how we approach the question. So that's why I was confused in the first part. Like the day we first tried to solve it, like there is nothing in this problem. Then I got to Siva sir and told me like you need to make a code. So are there any doubts? Like,
I think that's it.
Ah,
Gautam, anything?
hello?
so I think everyone's clear.
Yeah.
Okay. Then
Okay.
let's stop the recording.